that down was so big. Still going up. It did go down. Saying down. Ooh. Oh, wow. That's really good. Down. Oh, it went down for real. So this model predicts whether the stock market or whatever time series is being drawn, is being shown to the model, is either going down or up. If you were to check at this point, the prediction was up, and then the market did indeed go up. This wasn't a correct one, so it's not perfect. This went down, did kind of go down, it went up. So I want to use this, but for crash 1000 or boom 1000, but for this specific video, I'll just be covering crash. You can just swap them out. So from the documentation, the model is going to give us predictions of either down or up. And then we'll need to install Ultralytics and Ultralytics Plus. We also need to have OpenCV. We'll be using this to draw the image. So the difference here, as you can see, is it's being passed an image, and then from that image it's making an inference of a prediction. So now the difference of what we'll be doing today is, since we already have the data from MT5, we'll be using that data to create programmatically an image and then feed that image to our model, and then the model will make a prediction off of that. So this will standardize the way the image, instead of, for example, going to like maybe MT4, MT5, like different interfaces, and then bring those images into the model. So if you were to go back to this documentation, there seems to be like a very standardized way of how they have pre-processed their images, but they haven't mentioned the exact formula of what they have done. So we'll have to figure that out ourselves. So from the community discussions, I ended up finding this code. So this person has taken that model and then made it work using a different kind of data type. So we'll be kind of redoing this code, but to suit our needs, to use the data we got from MT5, using Python. So to make this work, I need you to come to this URL. I'm going to link it below. Then come to Files and Versions. Then download this best.pt, because this is the trained model. You'll click on this download button, and then make sure you save that in your folder best.pt, like this is our root folder. On top of that, you need to install some things. If you were to go back here, you need to install Ultralytics Plus and Ultralytics. So this does install so many dependencies. I've listed all of them here. So if this is your first time on this code, you can just run the requirements.txt. So that will be pip install -r and then the requirements.txt. I've installed all this. It might take a couple of minutes to finish if this is your first time running it. So just to like have a quick run through of what we did yesterday. So yesterday we had our deriv account. We were logging into MT5 using this function, the authenticate to MT5, and then using the historic data to save the data, the specific data we needed. So we used our symbol, start date, end date, which we defined up here. So the symbol was crash 1000 index. We also use the PyTZ module to define our time zone, the date time to get the time. So for this specific example, I want us to like have a huge data set. So let's go back like 2 years, so 2022 to 1st of 2024. Let's first save this data. I also want this to be in, we can use the 1 day or the M1, whichever works for you. So the time frame is 1 day. I'm going to change this. I'm going to remove, so comment out on this, and then the time frame will just be, I think it will be 1 day. I'm not sure. That's why I'm not doing this whole time frame thing, but let's just run it. Let me clear this first. So Python save data.py, data work. Oh no, wait, it commented out this. So to go back to data, and we have this. Okay, so the days is kind of weird, but we'll take it. Create a file, make predictions.py. I want us to use this file as a reference on what is happening. So I want to separate this as our own, as another function that's just going to load the model instead of having it all as like one big file. I'm going to define that first. So the error line is the same as we had yesterday. Just prints out the message, the error message on the console. Then we load the model. I'm just going to define the main with that. So we need a local model path. So let's define that up here. Oops, sorry. I didn't copy it. So this will be best.pt. So that's our model path. So what we want to happen in this load model function is we need to use YOLO. You only look once. I think that's the full name. Yeah. Going back to the documentation. Yeah, we need to import YOLO, and then using YOLO we can then load the model and set the parameters. I have to do that there. So once I've loaded YOLO, the next part is loading the model and then setting the model parameters and returning the model right here. So the model path is this. We pass that to our model, then we set the model parameters, then we return the model. So the number of detections per image is, if you were to go back to this, you can see like this has so many, 1, 2, 3, 4, 5. This has 3. So if you want to just detect 1 or 2, which will also be determined by how many bars you're plotting at one point, this is the setting to tinker with. Now that we have a model, we are loading the model. The next part will be to draw the data that we have saved as a CSV. So this is what we'll be using. So maybe we can start with that. We can start with the CSV path and then go to the CSV, right click and copy relative path. Since this is Windows, and that will bring an error, just change that to, is that a /? I think so, yeah. So the CSV path, this is where we'll be getting the data from. We also need to import pandas so that we can use that to read the CSV. So we have pandas, we have the CSV. Now we just need a function that will be doing the actual drawing. I'm going to call that draw data. I'm going to define it, maybe just below here. So it's going to take the CSV path, an images folder where we'll be saving the images. If you were to go back here, see these images that are generated, we'll have that saved into an images folder, and then it's also going to take the model that will be doing the actual predictions. Okay, so and then this, we can now use this here. So draw data, CSV path. So the model is already coming from the load model. The CSV path, instead we've called it CSV path for symbol. The images folder, we need to define this. So to define this, what we can do is import the symbol name, the start date, the formatted date, and the end formatted date, since we already had that from save data. We need a lot of this information. So what I can do, the lazy approach will be just paste this. We'll need to create the folder, the images folder, that is this function. So what this does is we check whether that folder exists, and if it's a directory, the folder path. If it doesn't exist, we actually create it. If it exists, we just print that the folder exists to the console. So we're importing this function in make predictions. The ideal way will be to just make like a function, like a file, a utility file where we have all the common functionalities, but I'm gonna clean up a bit later. Since we're doing that, I think it will be prudent to comment out this, because this one, once you import the saved data, it's going to actually run that file, and we just want the imports. So with these imports, now let's create our folder name. So we're going to call it, it's going to be in images, and then the symbol, which is crash 1000 index. The start date will be now from 2022 and end date 2024. And then this images folder is what we'll be passing in here in draw data. This. Okay, so now let's do the actual drawing. So the first thing will be creating the images folder. I want to do that first because let's keep forgetting. So we'll create the folder, format this. We can actually test this out first. Let me just comment out the model thing. Okay, let me just leave it so that we can see whether it will be loaded. But instead we're doing Python, then make predictions. So this will download something else, the YOLO 8N. This is like another model. You can see it's being partially downloaded. Once it's done, created folder successfully. So you see we created images and then crash 1000 from 2022 to 2024. If we were to run this again, it's going to say folder already exists. You can see in the second pass, once you're loading the model, we don't get to download this again. So the model is being loaded, the folder is being created. So for now, to just speed things up, I'm going to comment out model and then just turn this into an empty string so that I can avoid that error. Now we have a folder, the images folder. Now we need to load the data from our CSV. So for that, we'll be using pandas. We've already imported that here as PD. We're going to use read CSV, then CSV path. Our CSV, the CSV we are reading is this one here. that we've just created. So once we've read the CSV, we can check out what is in the CSV using now the data frame, df.head. Can check out the first 10 items in the data frame. So we have columns, time, open, high, low, close, ticket volume, spread, and real volume. Okay. So with this, we need to first of all normalize our highs and our lows. For this, I'm using high and low. So this high and low. If you want, you can try out using open and close, but for this, I'm just using high and low. So I'll first normalize. So normalizing turns the values to a value between 0 and 1. So like this, open will find what is the value of the open at 7456.49 in a range of 0 to 1. Once we have normalized it, we'll then scale those values so that they can fit the image we want. So for a start, let's define what we want in an image. So the image has a height, it has a width. Let's just go back here. So we have a height, we have a width. You can also see it's like a very specific number of bars being plotted. For now, I'm just going to eyeball that to 300. So let's define those first. So the height, the bars, and the width. I'm going to let the height and the width be the same so that it's a square. And then the number of bars you're plotting will be 300. On each image will be 300. So what I want is this first image will have like from bar 1 to 300. Then this one will have from bar 2 to 301, then 303. So it's like we are subtracting. We keep moving up, plus 1, plus 1, plus 1. So we'll have like this kind of a moving thing, moving images, which if you stitch together will actually make a video, because this is supposed to be used on videos. Well, videos are like very many images taken to very short intervals and then like stitched together. So that is the idea. That is why we had to get data yesterday. Let's start by the normalization. And then once we normalize, we'll then scale those values that are between 0 to 1 to fit our image that's 500 by 500 pixels. So to normalize, the columns I'm normalizing are the high and the low. You can choose to do this for open and close. So for the normalization, I'm doing this on these two columns, the high and the low. And then from the normalization, I'm going to scale the values so that they can fit into our image that will be 500 by 500. I'm also leaving like a space of 20 pixels so that it has like some space. It's not like covering from corner to corner. So after we've done the scaling, the next part will be now to start the iteration, the actual drawing. So for a start, the start candle will be 1, the end candle will be the bars. So like I was saying here, candle 1 and candle 300, then candle 2, 301, like that. So that is the start candle and the end candle. So initially the end candle will be equal to 300. So on every plot, I will be doing an increment of the counter. So let's start that actually. So the chart counter will start at 1 and then go all the way to the end of the data frame, all the values we have, but minus bars. This is because the last candle will need to also have values of the last 300 bars. So with that, I'm going to also import NumPy. We'll be using NumPy to do this. Import NumPy as NP. So with NumPy, the first thing we'll initialize an empty array that has just zeros, and then a three-dimensional array because colors are RGB. So for every point, we need to have a red, green, and blue. Where is that? It's here. This needs to move. Yes. So we are starting it as just zeros of 500 by 500 by 500. Like it's a three-dimensional array. That's why we have 3 here. And then we're filling it with 255. So it will be like white. We're setting it off as white. Then we can now start plotting each point on this white canvas. So let's do that. So to plot each point, we're also doing the iteration again. We'll start from the start candle and the end candle plus 1. Then we'll be getting the coordinates. It's like we're drawing triangles, little triangles, which are now the bars on this white canvas that we have. And then from there, we will be determining if the candlesticks are bullish or bearish. If a candlestick has the close greater than the open, that's a bullish candle, it's supposed to be red. If it has the open less than the close, that's a bearish candle, which is supposed to be green. But when I was testing this out, for whatever reason, red was not working. I had to, once I switched out the red to blue, so this will be RGB. So RGB becomes blue, the last one. Otherwise, if we're doing red, this will be 255. So there's some things we haven't initialized yet: the candle width, the thickness, and x1. So x is the starting coordinate. Let me start those here. So we'll start at 1. We'll be incrementing x. X is like our x-axis. We're starting at 1. So after we plot the first point, we increment that we can keep drawing 1 pixel to the right. Then the thickness of the candle, I'm setting it to 3, and the candle width to 2. You can play along with this. I found this to be working super well. We also need to import CV2, which is the plotting library we're using, which is OpenCV. It's short for OpenCV. And lastly, we also need to increment x. So on every iteration, we're moving x plus 1 so that we can plot the next one, the next point. So this is just plotting the point on the first chart. So this is a for loop for the image, and then this we're plotting each point on that image. Hope that makes sense. So now that we have the points plotted, we want to give this to our model. Once we're done, so this is the for loop. Once you're done plotting all the points, we want to give our model those points to make a prediction after the for loop. Yes. But before we so for every chart that we create, we give that to the model to make a prediction. Oh, it's quite a tongue twister, to be honest. So in these results, this is where we'll be having the actual predictions and the boxes that we need to draw. So the boxes, we will need to use render result. That also comes from YOLO here. render results, we have to import that. With render imported, now we just need to take the prediction, draw the boxes of the prediction, and then draw the final image that has our points plus the boxes drawn on top. So we use render result to give it the model and then the graph. Note that the graph now has the rectangles, because you can see at this point we did draw each point on the graph. And now the predictions that the model gave. So it's drawing that on top of the image that we've given it. So to save this, I'm just saving it as graph underscore counter. So these are the number of individual images we'll be having. And then the output path will be our images folder that we already created up here, which is also here. And then the file name will just be graph. You can name this to whatever you want to even crash, like something more descriptive, but I'm just saying graph, the chart counter.jpg, and then we use OpenCV to write that to the output path. Now the entire final thing. So let's run this and see if it's working. Fingers crossed. Has no attribute to predict. What did I do? Oh yeah, I know what's wrong. The model is not actually a model, it's just a string. Oh yes, it's working. You can see we're even printing out the predictions. So this is really heavy on my laptop. I'm gonna let this run, then come back. Yeah, let's see. Is it even moving? Oh yeah, it is. Oh. So as you can tell, the main challenge you have, let's just go back. You can see around here, it says up and then it went up. So it's gonna keep going up. Seems like there's a lot of ups. So it's going down, down. Oh, it went down for real. That was the first down, then it did go down for real. Whoa. But now it's saying down again, but we're going up. You know, they're so squeezed you can't even see much, but let's see whether that goes down. Oh, it did go down. Damn. It's not actually bad. So we definitely need to backtest, number one. We also need to decide on whether this is the best approach to do it. Because, for example, if we just go back here, we have so many predictions. This slideshow thing just did the thing. So we have so many predictions. We can pause. We have so many predictions. And on every new bar, it's different. So that will be a problem. Let's see whether it goes down. That down was so big. It's going up. It did go down. It's saying down. Ooh. Oh, wow. That's really good. I'd backtested with like a few data points, but I didn't know it was this good. Let's see whether it goes up. No, it's not going up. Wait, it's kind of going up, right? Oh, wow. This is so good. It really goes up. Now it's saying down. It's a bit confusing. So yeah, it's working. So now we need to backtest. We definitely need to backtest and see how good it works. And maybe in a future video, maybe the next part of this video will be like making it real time, work with actual real time data. So let's start by defining a backtest function. So this backtest function will take the predictions, so the up or down, and then we take the close price and then the actual class. So we already have the predictions, we just need the close and the actual classes to make this work. Let me format this. I don't know why Python keeps doing this, the pylons. Awesome. So the backtest, I want the backtest to happen after we are done with everything. I want the backtest to happen here after we are done with all the predictions, with all the drawing. I want the backtest to happen here. So we want it to have a return on the percentage of wins. So I'm gonna let that happen right here. Oops. Copied the wrong one. I really like this typing extension. I don't have to keep doing it. So we're taking the prediction close, price, and the actual outcome. We need to define those first. I'm going to define those here. So the prediction close, and the actual outcome will all be empty lists for a start. With the empty lists, so if we're to go down, we're printing out whether it's up or down. That was it here. We're printing out whether it's up or down. So let's create another list that will be storing the current predictions. And then we'll be pushing our current predictions to this list right here. Can even do a fancy print here. So if we were to go back to those images, where is our slideshow? So we have like, this has 1, 2, 3, 4, 5. As you remember, we did set the maximum to 5. I would imagine this will be more. Where is our load model? We set this to 5. It will be more. So now what I want to do, I want to take these down, like the most recent prediction and use that as a backtest. However, as you can imagine, it wouldn't work as well in a scenario like this when the price is currently here, yet the prediction is so far back. So that will be a problem, but let's see how it performs. So you see here, the prediction will still be up though, but yeah, that is the current stress about this. So maybe once we do incorporate this to like a working, a real life scenario, like a real time scenario, we'll use other indicators to try and help. So going down, yes. So for the current prediction, I want to append. So we've appended the, what do you call them? We've currently appended the class name so that it's up or down, right? Once we've appended the classes, now what we need to do is to get the most recent, I don't know whether to call it the last or the most recent, like the most recent prediction, whether it's this up, and ignore these others. I hope that makes sense. So this is a list. This is giving us a list of the 5 of them. So now we want the last index. Yes, that's what I'm trying to say. So once we have all the current predictions, now let's create a condition that loops through those predictions, appends them to our prediction list, and then also get the close at that particular point and get the actual outcome. So I'm going to do that here. So this is just a check to make sure we still have, what do you call it? We're not trying to get predictions that don't exist. So we get the prediction in current pred. So this, remember, this is like up, down, up, down, up, down, like there are 5. Then we get the most recent, which is the last index. You can use -1 for that. And then the close price at that specific point. So at any one time, very last close, if we were to go back to this, you remember we were saying the first bar is 1, the last bar is 300, right? So if we're in chart 1, if we're in chart 0, let's say we're in chart 0, the last bar will be 300 plus 0. If we're in chart 10, the last bar will be 300 plus 10. So that is why I'm using the chart counter plus the bars to get what actually happened, the closing price that time. And then the actual outcome would then be +1, because if right now we are predicting, let's just take this. If right now, let's say this is 1 and this is 300, and we're predicting this will be going up. So we are predicting that 301 will be going up. That's why I'm doing +1 to get the actual outcome of that specific index. And yeah, so actual outcome, prediction close, we're giving that to our backtest. So now doing the actual backtest. So for the actual backtest is within the pass. We want to count how many we won, how many we lost. So we can start by initializing that. So we're starting at 0. So when the count is 0, the lost is 0 when we're initially starting. And then from there, we can loop through our prediction close close price and the actual class. For this, we'll be using a zip. So for the prediction, close price, and actual class in zip, so this takes them, so this allows us to iterate through all this at once, like whatever is in index 0, index 0, index 0, all at once. So if the prediction is down and the actual class is less than the close price, if we were to go back to what the actual class is, we should actually call it actual outcome, because that's what I'm passing here, actual outcome. So let's just say that it's actual outcome. So whatever the actual outcome is, I'm going to change this right now. So whatever the actual outcome is, if the actual outcome is less than the close price, it does mean that the price did indeed go down, so we actually won. So otherwise, the otherwise will be whether it's greater than or equal to. If the price was at the same level, we would assume that's a loss. So that's why we're incrementing the loss. We also needed to get the total, by the way. The total will be the length of all our predictions. Yeah. What has not been formatted? Surely can't be that. That should fix it, yes. So going back to this, if the prediction is up and the actual class, we said we're going to call this actual outcome. We have called it here. Let me change that real quick. So the actual outcome is being passed in actual classes, actual outcome. Do I call this actual class? The actual, I'm just going to call it that I don't confuse them. The actual outcome. Okay. So if the prediction is up and the actual outcome was greater than the close, we are considering it that we won, else we lost. And then we're returning the total percentage. Yeah, I think that's pretty much it. Let's just run this and see. Yeah, this is what I was saying. We usually have, it is a list of the predictions that we have, which can go up to a maximum of 5. So we're just drawing over this again. Should have done this fast because my laptop is humming down. Well, I don't think this changes anything here. It's all the same, to be honest. Maybe next time we should introduce like a database, or we shall save this to a JSON. Okay, so it seems our model has a 49% win rate, which is not good. However, considering all these problems we are having on just making it predict the most recent, that's not too bad. So maybe what we can do is reduce the number of bars we are plotting at any one time to just show like maybe 20 or 30. Yeah, maybe like 10 or 20. Then maybe that will fix our problem. But however, this is really good considering what we are facing. So I'm gonna leave this at that. Then I'm gonna pick this up and make this work for a real-time scenario. Like now make a bot that does use this model in real time.